Your thoughts on the conversation so far?
So we should not be surprised because human nature has not changed. So we can go back countless years and we might have forgotten about it, but if you read your history books, we want the same things that we wanted 100 years ago. So we had the gramophone, we had the record, we had the tape, we had the CD player, we have the MP3 player, we have music streaming. We've always wanted to listen to music as much as possible, wherever we wanted to, and as convenient and cheaply as possible. That has not changed. So our desires and our wishes and our wants remain. How we achieve those things, though, is clearly changed by technology and innovation. Therefore, we should not be surprised if the technology is abused. And we should also bear in mind, and perhaps this is reflected in the OpenAI board, how much power corrupts us once we have it. So we might be ethical and transparent and trustworthy as we aspire to be in power. Once we acquire power and we have it for a period of time, human nature, and you can look at leaders all the way back, we change as we are, right? So that's a frailty and a weakness in humankind. Therefore, none of this should surprise us. We need guardrails. The problem is that when it comes to regulation, regulation fights the battles that have already been fought. So getting regulation which is forward-looking is extremely difficult, hence letters that have one sentence in them, which really set out a desire, a conceptual desire, and how that then translates into the everyday, that's where the challenge lies.
We trust the big global corporates. I see absolutely nothing that would make me big that they believe that they're working for the betterment of humanity. I'm sorry, don't get it. Please come back on that, Scott. And then we can loop around on that as well.
Well, I think one of the issues is we're also making some big assumptions that how our employees, how our teams are going to actually embrace this technology. There was a very interesting paper recently where they took a machine learning algorithm, not generative AI, but a traditional machine learning algorithm that was used to identify disease in x-rays, and it was better than 2/3 of radiologists. They took 200 radiologists, paired them up with that AI, and they found that they performed worse than just having the AI alone, because there was a distrust. The doctors didn't know how this worked. And so they believed that, it was making the wrong conclusions. Okay. In fact, some folks in decision science say if you have an algorithm that works better than 80% of people, you should just go with the algorithm. Okay, because if you just add a person into this, it's not going to yield any better results. And that's something that, I thought that, well, of course it's going to have a better result, because I've seen, like in chess, they have these centaurs, right? You pair a human team with an AI, and they are the best at chess, even better than a machine learning algorithm by itself. So I thought, of course, you're going to combine these things and it's going to make it better. That turns out that's maybe not the case. So I think there's also some danger in how we think about how our employees are going to use these systems, whether they're going to trust it, whether it's going to make them better or not.
I imagine that you are as far close to the cutting edge as it can get. Is that true? I mean, I imagine that you are really pushing the envelope back on almost a daily basis in terms of the things that you're exploring, and both in terms of what they are and the applications you can bring to the game with them.
I would like to think so. Certainly at Berkeley, we're in a very fun position where we get to work with some of the brightest minds in AI constantly. Berkeley, along with our friends at Stanford and MIT, are usually ranked the #1 AI research lab in the world. And we get to sort of put out the cutting edge and push the cutting edge forward sort of on a daily basis. So if you look at things like diffusion models, they were invented by my friends who sit in the seat right next to me. And so I really do get to benefit from being around a lot of really smart people, and I pretend to be one as well right next to them. It's been a really fascinating conversation so far that I'm hoping to also add some interesting comments towards. But just as a way of background, my research focuses on artificial intelligence for humanitarian assistance and disaster response. I used to run a research lab at Carnegie Mellon for 5 years on this topic. currently doing this work at Berkeley, and with a variety of other organizations in the U.S. government, and really am focused on some of the issues that our panelists have brought up, like Scott and Danietta, on things like, how do we actually trust the models that we're deploying? Sort of what are the issues at the intersection of the machine and the human? What are the issues in getting operators who are very stuck in traditional ways to adopt and actually change their workflows in response to more AI augmented things or mechanisms? And so, these are sort of the issues that we're tackling on a day-to-day basis. There were some comments, brought up about how machine learning methods are currently untrusted because of either the data that they're being currently trained on, or because, the fact that, generative AI models are able to hallucinate and create sort of facts when there are none. A lot of that is rapidly changing. Scott brought up a great analogy of this noisy intermediate scale quantum era that we find ourselves in. And so, startups that existed 10 years ago sort of went in with the assumption that in 10 years from now, we'll have all this solved. And while that's not the case, right, we still deal with a good amount of quantum noise. The picture as it stands now is a lot better than the picture it was 10 years ago. Like we 10 years ago, we were dealing with 1 or 2 qubits in a research lab, to now where we have full-scale production chips with at least 100 qubits that are being used in real applications all around the world, right? Rigetti, for example, is using quantum chips to do weather simulations. Similarly, the field of AI is actually moving, I would argue, much faster than quantum computing was. For example, hallucinations, right? Language models are unable to deal with false premises, right? Or large multimodal language models, especially. So if you ask a large multimodal language model, you give it an image and you give it a prompt like find a picture of a banana in in David's Zoom screen right now, there is no banana, but I'm telling it there is, and I'm telling you to find it. So it'll give me a segmentation mask of something, right? Even though it doesn't exist. And so, that's a huge problem. You'd say that's a hallucination. Why is it making up this information? This seems like a really hard problem to solve. Well, with a paper that we just submitted to CVPR last week, we solved that problem. LMMs no longer, hallucinate under false premises. And we can prove that through a variety of tests, and we can actually quantify under what situations they might still hallucinate and how to sort of fix those situations going forward as well. And so I would be, very optimistic about, using artificial intelligence methods in increasingly trusted environments, because I totally believe that this problem of hallucination is a very, very short-term problem. And we have some of the best minds in the world working on this all around the world all the time, right? Nothing else is capturing the world's attention anything more so than AI. Putting that into sort of humanitarian context, in this context of disaster risk management, we've been deploying our research over to first responders for the last decade now. One of the research I'm most well known for is being the first to assess building damage from satellite imagery, right? So given a massive satellite image of 1,000 square kilometers, our machine learning models are able to tell you exactly which buildings are damaged and to what degree they're damaged in about 30 to 40 seconds. So we've been deploying these to CAL FIRE. We've deployed these to our partners in the United Nations, World Bank. We've been deploying them to our partners in Ukraine, who've been using them to assess damage all across the country, to assess the scope of Russian war crimes, for example. And the models, you'd say, like, how can I trust that? How can I trust this model when I have a person, going on the ground, sort of counting the damaged buildings by hand? And it turns out that these models are extremely powerful. Very recently, we had this massive earthquake in Turkey and Syria. And this was one of the unique places in which we actually had a very wide network of sensors distributed all throughout Turkey that were monitoring building health and structural integrity all across many different cities in Turkey. And so when the earthquake happened, within 4 hours, we had a satellite image of the city of Marash. And within an additional 30 seconds, our models had created an inference for all 400,000 buildings in the city. And we were estimating that about 7.5% of buildings in the area were damaged from nothing else but top-down satellite imagery captured from 10 kilometers above the Earth's surface. In the ensuing months, right, in the next 2 months, the government of Turkey very rapidly, by human standards, by manual standards, conducted a damage assessment of every single building in that city. Took them 2 months and a team of a lot of people to actually accomplish this task. And combined with the data that we had from the sensors, they estimated about 6.7% of the buildings in Turkey were damaged. Sorry, not Turkey, in Marash specifically. And so our model was able to generate a prediction that was within 1% of accuracy of the ground truth from nothing but aerial imagery. And in fact, because of the speed of the assessment, we're able to actually help the first responders shape their search and rescue efforts instead of just doing assessment of, let's say, how much money is needed to reconstruct the city afterwards. And so the technology is moving rapidly. It's moving very quickly. And we've been deploying in sort of all of these contexts that we care about in the world of risk management on a daily basis. We faced issues of the kind that Scott mentioned in that, we have this powerful technology. We've shown that it works, quantitatively shown that it works repeatedly. Yet, traditional players in the space are reluctant to pick it up, right? Some in part because they're unfamiliar with technology as a whole, right? As you mentioned, the field of risk management is filled with a lot of 60-something-year-olds who still don't know how to fully use smartphones. And now you're asking them to use advanced AI-based technologies to solve a problem. And it just doesn't work for them. At least the products that we have designed aren't meant for them, right? And that's an issue on the engineer's side and not on the user side. It's not like a 60 or something all of a sudden, is stupid. It's just more so that the product was not built for them in mind. So one of the biggest issues that we've been trying to solve is how do we build better advanced technology solutions, ones that incorporate AI, in a way that an untrusting player, third party, can still use it effectively, right, iteratively, human in the loop, to still achieve a greater outcome at the end, right? So instead of having a radiologist sort of fighting the AI algorithm at every point in the decision, leading to worse outcomes, how do we actually incorporate the lack of trust, or maybe what the better way to phrase it is increased verification in the pipeline to actually benefit the overall pipeline, right? And how do we actually create applications that are usable by an audience that is not as tech literate as, let's say, someone who's in Gen Z. And so we've had great success in sort of deploying these solutions out to firefighters in California, out to our partners in Ukraine, where almost no thought is needed. There's almost no contention between the user and the technology anymore, and we're able to then observe greater gains in efficacy downstream. And I would sort of highlight this as a critical thing is, there's so much stuff out there now in the field of AI, which is and a lot of stuff at the cutting edge is now available to the lay person, right? When I, as a researcher, publish my paper and I publish my code openly, that code is now being distributed widely to lay audiences, people who aren't AI researchers. And so they get all the knobs and the buttons and the settings that I, as an AI researcher, think that others would want to use. But then lay people are trying to use the same thing to accomplish something at the end of the day, right? Like count damaged buildings. And it doesn't work for them. They're like, I have no idea what a temperature setting is. I have no idea, what this knob does. So finding ways.
I want to make sure we can go around and say, do you want to? I mean, there's a lot of stuff there. Do you want to sort of bring that to a diamond point of solution there, not solution, but conclusion, and then we can go around the table.
So I was just getting to the last sentence, which was if we can find a way to work iteratively with end users, right, in the disaster community, to figure out what their pain points are from a human-computer interaction perspective, and sort of work with AI researcher in the loop to build those solutions, I think we'll be in a lot better state. And a lot of these concerns that we're sharing in the panel today won't be true, let's say, hopefully a year from now.
The black box scenario is tricky. So I mentioned earlier, we work on workforce deployments. And if you're going to say to the head of risk, we think you should deploy your workforce in X area, if it agrees with the intuition and the sense that the decision maker has, it's all very well and good. But if the AI suggests that the workforce are deployed in another area which the decision maker does not agree with, they're going to ask the question. And I had this discussion with one of my colleagues. So one also needs to be careful that the promise is great, but when it's challenged by a normal human being, who's going to really trust a co-pilot, a decision support system, if they can't look into that black box and actually shine a light? And for us, for example, we need to be careful when we deploy our applications that you can work on it for a long time, you deploy it, and then the client says, actually, that's great, but I don't agree with it, and you can't defend it, therefore I don't want it. And that's a big issue, right? So you need to also be very selective with how you generate the decision support system.